Hi, today is day one of working on the Rittenhouse RCM4 Master Station, that's this over here, that was featured in the first video of this repair series. Some of the parts showed up today. They actually showed up a day earlier than I expected, and I had a little bit of time this afternoon, so I thought I would sort of get started on it. It seemed to me that the first thing to do, which is what I normally like to do, is let's get the power supply taken care of first and make sure that that's in good working order, and then we can move on to the other things. So this is the amplifier power supply module compartment, whatever you want to call it, and this is the primary power supply filter capacitor, bridge rectifier. It's got some ceramic caps on it for a little bit of filtering to take the edge off things. As you can see, this thing is ginormous. It is. So here, we'll do this. We'll do the Dr. Pepper can comparison. So here's a can of Dr. Pepper, and here's this thing. It's not quite as tall, and it's about 50% diameter of it, but it's a big old giant chunky thing. And to show you how the world has changed a lot, so this is one that I ordered. This is the same exact value in capacitance and in voltage. I believe it's the correct one. Yes, same one. So this is 3600 microfarad at 35 volts. And this is the modern day equivalent of it. This is also 3600 at 35 volts. This is a 105 degree rated cap, so it will last virtually forever in this. And as you can see, it is tiny. It is half the diameter of this, which is half the diameter of the Dr. Pepper can, and it is 1, 2, 3. It is 1/3 the height. So it's really, really, really small. The way this board assembly thing is constructed is kind of weird. So this is sort of a hand-built assembly. It's all mounted on this little square, I guess in quotes, circuit board, although it's not really a circuit board. It's not even fiberglass. It's some kind of like fibery, papery kind of material. I don't know what you call it exactly, but it's not the best thing in the world. The leads from the capacitor go through eyelets in the center of it. That's this big wire here and this other little short wire over here. That's the plus, that's the minus. And then you've got 4 diodes on it in a bridge rectifier configuration, and then you've got these ceramic capacitors. The ceramic capacitors need to get replaced anyway because this one was already broken. It wasn't broken, it was broke more when I took this out of the set, but it was already cracked, and that's not good. So there isn't anything about this. This isn't, anything that's difficult to really create, but it's the wrong form factor for today's project. So what I decided to do, because everybody likes to think they're clever sometimes, is I ordered the parts that I needed. I ordered the little blue capacitor. I ordered the little, where are they? The little ceramic filter caps. These are the modern ones. They're orange. And diodes, I got a lot of diodes, so that's not a problem. So what I decided to do was to take a proper little fiberglass circuit board and basically recreate it in a similar size footprint, although more suited for the little tiny blue capacitor. The other thing that's kind of weird on this one is these 3 filter caps, that one, and that one are on the top side, but this one's on the bottom because the capacitor takes up too much space on the board and there wasn't any room to get it across, and I don't know. That's the way they decided to do it. I suppose this little square piece of board material is something that was commonly available, and it's like, I know how we can fix it, so we'll just do it that way. I just took a little project board. I keep different sizes of these on hand because lots of intercom repairs nowadays, you have to deal with things like this to create something like this, and that's what these are for. So basically what I did was I put the capacitor in the middle. I put the 4 diodes in the correct configuration around it. I put the 4 ceramic filter caps, the orange ones, and then twisted it all together on the underside. A little project boardy thing. It's not really integral to how this is made. It's just a convenient piece of material. It's already got all the little holes drilled in it, all the little 1mm holes, so all the leads go through. And it's just a matter of putting all the through-hole components into basically onto the board. They're all on the top side, of course, and then all the leads in the four corners come together, and I just twisted them together. And then to make it easier to mount, so this one, this long lead right here, we'll get those out of the way. This long lead right here, this is the positive lead out of the big capacitor, and this one over here that sticks out on the side, which maybe you can see, that's the negative lead, and it goes across the bottom of the board diagonally through the eyelet. And then, so this capacitor would have had really long leads on it. They would be like probably 3 or 4 inches long, which you're not going to find that today. Although you can always twist them and solder them, and that'd be all fine. So I just decided it would be easier to make up little wiring harnesses so this can sit. It gives me more flexibility on how this is going to sit in the bracket, which I don't know that part yet. I have to figure it out. I may drill a couple little holes and make some little standoffs and use some machine screws and nuts and washers or something and find a way to mount it in here. Be better if I could mount it this way. Make it sort of sideways like this. But we'll figure that out once we get it all in place and wired up. So I decided it would be easier just to make it with wiring harnesses, and what I decided to do was I duplicated the original wire colors here. The brown wires are the AC input from the low voltage transformer, and then the other two corners, which would be, well, this corner and ultimately this corner because it jumps across. The positive out of the filter capacitor I made orange and purple because I got a lot of orange and purple, and you don't use a lot of orange and purple, and it's easy to distinguish that way. And there's already orange and purple wires in the harness, so you know it all matches. So I already hooked this up, and I put AC voltage to it. In fact, I can do that now. The workbench is kind of messy at the moment. So let's see if we can wire this up here real quick. Power supply is turned off. Our brown leads are our AC leads, the input to the bridge rectifier, like that, and our orange and purple are our positive and negative. And if we power this up, now it's powered up. No smoke, yay! If there's no smoke, that means there's no flames. If there's no flames, that means there's no running and screaming. Oh, so if we hook this up here like this, that's backwards. Do it this way. So we've got, just so you know, we got 18.7 volt AC input because this works on a 16 volt transformer, and so line voltage 18.7 is good. And then if we go to DC, here and here, we got 24.6 volts DC output, which is great. And that proves, and this, you should always do this when you make something up like this, you should prove out that you did your job properly before you install it in the unit and turn it on for the first time and then blow something up because you did it wrong. And you wouldn't blow up the intercom, you would just blow up your newly little built power supply board. This is ready to go. I'm going to put this in place. I've got another filter capacitor. We should turn that off. I've got this one that I've got to deal with also. This is a 2000 microfarad at 30 volts, and this one was lying in here like this, like this, down in here like this. It's got to get wired up also. So the new one was not a part I had to order, I don't think. Let me check and see. Yeah, I did. So again, and yes, always order extra because you might mess up, and if you only ordered one, then you're stuck and you got to reorder and pay the shipping, and it holds up the project, and that's all a pain in the neck. So here's our 2000 microfarad at 35 volts. As you can see, it's probably 20% smaller diameter, but again, it's little less than half as big in height. So it's a very much smaller one, but this just sat down in here and then was wired up to the terminal strip, so that's pretty easy. Anyway, that's what I'm working on now. More progress to go. The owner of the set did decide to go ahead, and I ordered replacement output transistors. They'll be here. They're already on their way, and they'll probably be here tomorrow or the next day or something like that. So, but those are the very last things to get put in. So we'll go over that when we get to it. That's all for now. Hope you found this interesting. If you did, give it a thumbs up on YouTube, and I'll see you on the next video.